For this problem here, we're going to try to find R, which is the interest rate needed to get a certain amount A based on the principal the principal invested for a certain amount of time. And then we want to try to find the interest rate that would achieve this. So there's kind of two different ways we could do this. I'm going to go one based on like what we did in the notes where I solve for the variable R first, right? Because R is not currently isolated. So if I do A equals P plus PRT, I can take away P from both sides, giving us A minus P equals PRT. And then to get R by itself, I need to divide by P and T on both sides. So we would get A minus P over P times T equals R. So notice in this case I've solved for R, and then I could plug those values in. So A was given as $1,500. The principal was $650, and then on bottom, $650 times T is 6 equals R. So I'm going to do this calculation, and you should try this on your own as well to see if you're getting the same thing. So 1,500 minus 650 would be 850 over, and then 650 times 6, 3,900 equals R. And then I want to divide those two. 850 divided by 3,900. This gives us a decimal of 0.219. Kind of goes on and on there. But let's give that a percent rate here. So remember, for a percent now, if I'm going to write this decimal as a percent, it goes 2 places to the right, giving us 21 point, why don't we go ahead and say 8% equals R. That's actually a pretty high interest rate. Sometimes when you get the randomization of like the problems on the homework, you might get something a little unrealistic because generally interest rates are not in the 20% range. It's usually, 4% to 8%, something like that. But nonetheless, the process is still all the same. Now, the other way that you could have done this problem is if you went back to the original. So this is kind of up to you, where you could plug those numbers in first and then solve for R in case you are not as comfortable working with all those variables yet. However, you should try to be comfortable with either of these methods in the long run. So plugging in 1,500 equals 650 plus 650 R times 6. And then solving this equation for R. You see, it's still not super simple anyways because there's still a lot of stuff going on. But nonetheless, you would take away 650, kind of like what we did over there, giving us 850 equals, and then 650 times 6 was the 3,900 R, and divide by 3,900, and I think you see you're getting the same answer regardless, so I'll just kind of jump to it. 21.8% equals R. Those would be the same intermediate steps when you do the division and then make it into a percent. So either way, I'll just kind of zoom out to get both on the screen at once, just so you can kind of see. It has really all the same pieces. I went a little bit quicker on the second one because they were numbers rather than variables, but ultimately it's all the same type of steps.